Alright, welcome to another video. I am still doing my math homework. I added a webcam, alright, for right there. I added a webcam for so you can see my hands, right, and what I'm doing. I thought that would be pretty cool. Someone asked for that in the comments, and I had another camera, so why not? I'm gonna try it, see how that works out. So okay, so on this, so the audio should sound a little different actually as well. I changed it, but I'm gonna see if it sounds better. So yeah, I'm gonna go back to doing this. I was doing this yesterday and I kind of forgot where I left off. Yeah, I remember doing this. Okay. I'm just doing homework, bro. I'm just gonna record and do homework. Why the hell not? Okay. Dude, I forgot which one. I think it was this one. I'm gonna do this one because I feel like I did the other ones. Okay. Yeah. Let's find a page that has enough space. Okay. Okay. So Susan plans on studying 4 different subjects. This summer is 100 days long, and Susan will study one of the 4 subjects each day. A schedule consists of a plan for which subject she will study on each day. So I think right there, this is counting permutations with repetition, probably. So let's see, there's 100 days. I would say that this is kind of like wait, actually, yeah, it's permutations, counting permutations with repetition. Bro, I forgot how to do that. Low-key forgot how to do that. How do I do this? So there's counting with repetition. The summer is 100 days. So you have just 100 days. It matters which days you pick the stuff. Okay, so permutations. Okay, so our alphabet is these 4 things, and we just want a string. Count how many strings we could make using this alphabet that is 100 digits, 100 characters long. Okay, I think that is 4 to the 100th, right? Because, yeah, I'm just gonna say that. Yeah, okay, that's good. Okay, how many ways can Susan plan her schedule if she decides that the number of days she studies each subject will be the same? Okay. Okay, so it's not with repetition anymore. We have a specific amount of each. So there's 4 subjects, is 100 days. That's 25, right? Yeah, okay. So we're gonna have 25 of each thing here. And we're gonna see, I think that's 100 factorial over 25 factorial times 25 factorial 4 times. Right? Yeah, that makes sense. Okay. Alright, very nice. Okay. I kind of forgot these. This one gave me trouble. I remember these two gave me trouble. I kind of don't want to do them again. I'm gonna continue. Alright, let's see. Alright, so... Okay. This is new to me. I don't think I ever did this. Yeah. I mean, I recognize this. Alright, so... Yeah. Seniors, you know? Honor roll, and then you count this one twice. So the number in here is this plus this minus this thing? Is that true? Wait, what? Wait, the number in a section in a section is the number of times those people have been counted. Oh. Wait, I didn't even read it. Okay, so everyone in seniors is counted once, so they each get a 1. Which makes sense. Okay. And then the seniors... Oh, there's like seniors in honor roll. So they get counted again. Okay. That's... So it's this and this minus like the double count time. That makes sense, right? What I don't get is like, what is this supposed to equal? Oh, it's a union. Oh yeah, okay. That's all, this whole thing is the left side, the middle, and then the right. Okay. Alright, well that makes sense. So the union of two sets is that, where you gotta take out the intersection. Okay. But let's see. I just want to make sure my face is being shown. Okay. Okay. So you roll two dice. This is kind of like permutations, because the order matters. They're saying there's a red one and a blue one, but whatever. There's 2 dice, and okay. It says how many outcomes are there in which at least one of the dice comes up 3. Okay, B is the set of outcomes in which the blue dice is 3, which is 6, because after the blue dice is 3, there are still 6 possibilities for the red dice to be whatever. Okay, and then R is the same thing for red, and their intersection contains 1 element. Yeah, and then the outcomes in which Yeah, it's this one. Okay, so the number of outcomes in which at least one of the dice comes up 3 is the union. Okay. Ooh. What? So at least one of the dice. You know, I don't get this. At least one of the die comes up 3 is the union. Well, this makes sense. Because if you just put the B, that would mean only the blue would be 3. If you put only the R, only the R would be blue, or 3. But if you put union, you're kind of like adding them. So it's like both of them could happen. Well, yeah, at least one of the dice comes up 3. Okay. I think I gotta get used to this. Okay. So it says a group contains 10 women, 8 left-handed people, 3 left-handed women. How many people are either left-handed or a woman? So they have to be one or the other, right? Is that what that means? Isn't that 10? Wait a minute. So wait. There's 10 women. Okay. I have to draw like a diagram, probably. So there's 10 women. Let's do the Venn diagram. 10 women for one circle, and the other circle is 8 left-handed people, I guess. And then in the intersection, there is 3 left-handed women. Right. Cool. 3 left-handed women, intersection. So I would add 10 plus 8 minus 3. I guess. It says how many people are either left-handed or women. So yeah, that's the union. Could be both. Cool. So it's 18 minus 3. I'm just gonna use the calculator for that one. 15. Right? 15? Yeah. Okay, so I didn't have to use a Venn diagram. I could have just wrote these letters. Yeah. Okay, so it says Erica goes swimming 3 days out of the 7 in a week. How many possibilities are there for her swim schedule if Erica goes swimming on Monday or Tuesday or both? Okay, so what? Monday, Tuesday or both? Whew. Okay, that makes sense. Yeah, so M is Erica goes swimming on Monday, T is Tuesday, and then if Erica does both, then that would be M union T. Okay, so yeah, Erica goes swimming 3 out of the 7. Hold up. So M equals so Erica goes swimming on Mondays, M, and that is how many possibilities to her swimming schedule. So, and she goes swimming 3 days of the 7. So, if she used Monday, then, okay, wait. So if she goes swimming Monday, she could go the rest of the 6 days. She has to choose 3 of the, from the 6 days. I mean, she has to choose 2 of the 6 days remaining. So I'm pretty sure that's 6, choose 2 for that. Okay. What is that? 15? Okay. And that's M, so T, Tuesday, I'm assuming is the same thing, because you're still just picking one day. Alright, so I'll just choose that. T is 15 as well. And their intersection, alright, is gonna be, I guess, 5, choose 1, because she picked 2 days to swim already, so she only has like 1 day left, so that's just 5. Okay, so if she were to swim on Monday or Tuesday, not necessarily both, that would be the union. Okay, so I just add them individually. 15 plus 15 minus the intersection is 25. Okay. Okay, that's pretty good. Okay, so how many positive integers less than 100 have at least one digit that is a 9? So it's going to be 1 through 99. How many of them have at least one digit that is a 9? Okay. So they're suggesting that I find the number of digits that are 9 for the ones place, and then also for the tens place, and then union them together, which makes sense, kind of. How many positive integers less than 100 have at least one digit? This confuses me. Oh man, 3 sets? No. No, 3 sets? Oh my god. Whatever, alright. Guys, I can't tell if I'm like too low or something. Yeah, it's too late now. Nah, bro, I keep messing with it, dude. I have to fix this. Alright. Let's do 150. More vertical space for my head. Okay. Please turn. Okay. I don't think it's turning. Can I go like this? That's cool. Okay. So. Okay, I get this. Because they say at least one digit. So that implies there's more than one digit, right? Like it could be 1 digit or 2 digits. And so that defines our set. So the first set would be the first digit, the second one would be the second digit, and then you just union them for all like the possibilities. Right? 1 digit. Yeah, that makes sense. Okay. So okay, let's calculate it. So ones place possibilities is just 1, right? Is it? No, it's not 1. I think it's 10, right? Isn't it 10? Because you have the ones digit, you're just picking 1 through 9. Only one of the digits is 9. And then now the possibilities for the other number is 10. Because you can choose 10 more digits. So I'm just gonna say that. And the 10's digit is gonna be the same, I guess. Okay, and then their intersection is gonna be 1, right? Isn't it gonna be 1 because you just have 99? 99 is the only like 2-digit 9 number. Yeah, I was looking here to see if they subtracted a 1 as well for this one. They did, so okay. So it's 10 plus 10 minus 1. 19. Cool. Okay. Okay. Very nice. God damn it. I don't want to do this. 3 sets? What is this, man? I don't want to... There's so many numbers here. 7 numbers? Jesus. I don't want to put 7 numbers in here. What is it? Can I just memorize the formula? This is... Like, this is too much, guys. This is too much. So you add all of them up individually. What? And then you subtract... What? Like A, B, B, C, A, B, B, C, and then A, C. And then you add all the intersection of all of them. What? Hold the phone, bro. Hold the phone. I think I can memorize that. Add them up. Subtract this intersection, this intersection, and this, and then you add the intersection of all of them. Bruh. Why? Why? I mean, I know why. Gotta do this homework, bro. Okay. Oh my god, what is this? That's a lot of numbers. That is a lot of numbers. Okay, let's read this. So a computer science department offers 3 lower division classes in a given quarter. Discrete math, digital logic, introductory programming. Okay, the department wants to know the number of students enrolled in any... Excuse me. God damn. I'm gonna drink something. I got a Gatorade here. Let me show you guys, alright? Let me have a little interaction going on here. This is Gatorade, my friends. It's sugar water. And that's it. I don't know. Let me see. Yeah, it says water, sugar, dextrose, citric acid, and a bunch of random other stuff. And this one bottle satisfies 41% of my daily sugar thing. What is it? Daily recommended intake? Whatever they call it. Whatever. Tastes good. Sugar. Alright. Don't worry, I have water. I have a huge bottle of water. And I drink it. Okay, so they want to know what do they want to know? The number of students enrolled in any of the 3 courses. So what, is that the union of all of them? What does that even mean? Oh, just in total. Oh, and that means you have to count them all once, so you don't count anybody more than once. Okay. That makes sense. That makes sense. So we got 3 sets. Okay. Because you can have students that are enrolled in multiple classes, I suppose. So that would make them count multiple times. That's the intersections. So that makes sense. Because if all the intersections were 0, then you would just be adding up all the sets individually, and you wouldn't have to like do this formula basically. Like all this other stuff on the right, you just wouldn't even need it. But since there are students that are in both, they exist in multiple sets, then they're gonna get counted more than once. So you gotta do the subtraction. Okay, that makes sense. Yeah, so the answer here is 325 for these numbers. So that's in total the students that are enrolled, the unique students in each of the sets, I guess. Okay, so what is this question? How many integers from 1 to 30 are divisible by 2, 3, or 5? I would just calculate this manually. I would just check everything, but that's not what they're trying to teach us. So A2 is a set of integers from 1 to 30 divisible by 2. This one's by 3, this one's by 5. And all you gotta do is union all of them. And this will be the integers that are divisible by all these numbers. And you gotta do the formula so they're not counted multiple times. That makes sense. But you know what? This is kind of weird because then you gotta like find the intersection, like numbers that are divisible by 2 and 3, 2 and 5. Wait, 2, 3, 3 and 5. 2, 3, 3, 5, 2 and 5, and 2, 3 and 5. Right? 2, 5, 3, 5, 2, 5. I think that, yeah. Okay, that's cool. But you do have to add the intersection of the last one. Okay. Okay. That's interesting. So I'm just gonna let this play out because I'm trying to get all the check marks right. So I gotta play this little animation, and when the animation is finished, I get a check mark, proof that I clicked through it. Alright, so there are 3 employees of a company, and they have each worked on 12 projects. Each pair of people have worked on 4 projects together, including one project that all 3 have worked on. What is the total number of projects? God damn it. Alright, let's see. I suspect we're supposed to union all of them, or find the intersection of all of them, or some weird thing with the formula. Gotta manipulate it or something. So, what is the total number of projects? What? Employees of a company have each worked on 12 projects. 12 projects. They each work. Okay, whatever. I'm just gonna do this. I'm gonna plug in the numbers. So we got A equals 12. F equals 12. J equals 12. Right? They've each individually worked on 12 projects in total. Each pair of people have worked on 4 projects together. right? So Anna Fred, Fred Jose, and Anna Jose have each worked on 4 projects. Okay. Right, so I'm just gonna start adding these up, I guess. So minus 4. So I'm gonna add them all up individually. 12 plus 12 plus 12 minus the intersections of the pairs thing, you know. Anna Jose, Fred Jose, and Anna Jose. So I subtract those. Then I add the intersection of all of them. And they say that all 3 of them have worked in one project. So add 1. What is the total number of projects? I guess I'm just gonna type it in the calculator and see what I get. I got 25. That's crazy. If this question wasn't on this homework assignment, I would not have known to use the formula. Not gonna lie. Cause the set of projects. That kind of makes sense actually. Cause it's like Anna has worked on 12 projects. And you just want to know in total, just in total, what is the project? So that's literally just a union. And they give you all the intermediate stuff. So, okay, I mean that makes sense. That actually kind of makes sense. I would be able to do this on a test. So, alright. Okay, so how many numbers in the range from 1 through 42 are divisible by 2, 3, or 7? Awesome. Me likey. Kinda. Alright. So, let's just say the divisible by 2 is like... Bro, how do I even count this? I just don't want to count this. Because how did they do it for this? Did they just... They just knew? They just counted all of them? 2, 3, 4, 5, 6, 7, 8, 9, 10. What is this? Is this the... What did they do for the intersection of all of them? That's this one, right? You count the you just count the dots. Dude, but I don't want to count freaking dots. There's so many dots. Oh my god. Is there like a quicker way? Alright. Let's count the dots. We'll just do it. Dude, the reason I don't want to do this is because so many times I've done problems like this where they just give you just gotta do a giant calculation, some stupid just some giant calculation, and I'm not a computer, so there's a chance of me just making one mistake, miscounting like a single dot, and then the calculation's wrong, and then the question is wrong. But I know that during a test I'll just be able to do it, but that's screwed. So I'm just gonna do it. Alright, wait, let's see how long. I wasn't planning for recording too long, but I don't know. I was thinking like an hour, but I don't know. I don't even know. It doesn't matter. Alright, so 1 through 42 divisible. God damn it. God damn it. Is this where I can use my programming knowledge? Should I program something that can do this? Nah, I shouldn't do that. God damn it. Alright, so I'll call it D2, divisible by 2, D3, D7, right? And then I gotta find the intersections of these, so D2 and D7, D3 and D7, wait. What did I do? This one, this one, this one, this one. The hell? Went out of order. I did 2, 7, 3, 7. I did 2, 3. Yeah, okay. And then the intersection of them all. Right. Okay, and this is from 1 to 42. Awesome. Super awesome. Okay, here we go, Python. Python online, let's just find something here. Okay. 1 to 42 by. Nah, I'm just gonna say divide by AB. We're gonna return A modulus B equals 0, because that's what that means. And then we're gonna do a loop range. We're gonna do a loop from 1 to 42. We're gonna print this out just in case. It goes 1 to 41, so let's do 43. Alright, okay, now it goes 1 to 42. Okay, so we are going to count these numbers. So, okay. The hell am I doing? Okay, wait, hold up. I'm going blank, guys. I'm going blank. Alright, so we got a bunch of variables. Alright, so we got a variable here. Let's just say D2 equals 0. Let's initialize all our variables. And let's do the intersections. So D2, D3. D3, D7, D2, D7, D2, D3, D7, okay. So we are going to count all of these, and then at the end, we're gonna apply the formula. Right, so we're gonna do the formula, so we're gonna do that, plus that, minus this, minus this, minus this, plus this one, D2, let's see if we done D2, 3, 7, that's what it is, right, 2, 3, 7, yeah, okay, 2, 3, 7, D2, D3, 2, 3, 3, 7, 2, 7, cool, okay, so we're gonna loop through this many times and just increment all of these. Actually, no, we're just gonna do a bunch of checks. Alright, so okay, so yeah. Alright. So if the number is divisible by 2, okay, we're gonna do D2 plus equals 1. Alright, we're gonna do we're gonna do a lot of these. Alright, we're gonna do a lot of these. If it's divisible by 3, right, we're gonna do D3 plus equals 1. And this thing needs to be longer. Okay, so we got that. How many do we have? 1, 2, 3, 4, 5, 6, 7. So we got 1, 2, 3, 4. What? 4, 5, 6, 7, right? 1, well, I can just check. So 2, 3, 7. 2, 7. Scroll is crazy. The 3 intersections, and this is gonna be the other one. So if it's divisible by 2 and 3, okay, and this is gonna be 3 and 7, and then this is gonna be 2 and 7. Okay, and this one is gonna be all 3 of them. Okay, 2, 3, and 7. Okay, and now let's do the variables. So D7. Alright, D2, D3, D7. 2 and 3, right? So we have 2. D2 is incremented. D3 is incremented. Here it's 3 and 7. Right, 3 and 7. Here it's 2 and 7. Okay, so we got 2, 2, 7, and we got 2, 3, and 7, and then, yeah, alright, let's run that. 68. Is this the correct? I don't know if this is correct. God damn it. What's the answer? 30? What? Oh, that was a pretty easy calculation. They just divided it. That's the number. You know how good, you know how real that is? How did I not get this? D2. Oh my god, guys. Oh, I'm so silly. I'm so silly. Because I put here the, oh, come on, guys. Look at this. That's my bad. My bad, bro. This is why you don't... This is why you don't program it, because it takes its own toll right there. Okay, of course. It's 30. Okay, first try. First try. First try, my friends. I don't know if there's too much code. Whatever. Okay. Oh my god. Do I have to? What is this? I don't really wanna. Nah, bro. You know, this sort of makes sense. This is like the combinations. The 2 pair, right? Oh, you alternate. So you add the 1 pairs, subtract the 2 pairs, add the 3 pairs, subtract the 4 pairs. So that kind of makes sense. That's kind of weird though. Is that how that works? It's like alternating. Yeah. Weird. Kind of weird, but I don't know where they came up with that. But that's pretty cool. God damn it. I'm gonna have to take a shot of Gatorade. That goddamn sugar water. Okay. Okay. So suppose the thing is used to compute the number of elements in a unit of 4 sets. Okay, so each set has 15 elements. The pairwise interactions has 5 elements each. The three-way intersections have 2 elements each. And the intersection of all of them have 1 element. What is the size of the union? Wouldn't you know it, I can add, subtract, this thing. Probably multiplying, just multiplying. Okay, let's test our theory. So I thought it was combinations, so I'm gonna try 6 choose 4. No, right? 6 choose 4? Wait, 4 choose 2. Yeah, so we have 4 elements choosing 2. We're gonna get 6 of these, right? 1, 2, 3, 4, 5, 6. So combinations, my friends, combinations. and that's gonna be whatever. So the amount of elements for this. How did they write this down? So this is it just wrote the letters here. 1 to n. Okay. 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 So yeah, and 4 choose 1 is just 4 is 4. Okay. So I'm gonna try to write this down. Okay. Alright, so each set has 15 elements. Okay, so individually, let's do that. So we have 15. So we got 15 times 4 choose 1. Right? Plus. Minus, right? Minus. You gotta do the alternation thingy. So minus something times 4 choose 2. Let me move this around. So we got 4 choose 1 times 15 minus 4 choose 2 times whatever those are equal to. 5 elements each for the pairs plus 4 choose 3 times whatever that equals. 2 elements minus 4 choose 4 times whatever that is, which is 1. Okay, let's use the trusty calculator. Right, so 4 choose 4 times, 4 choose 1 times 15 minus 4 choose 2 times 5 plus 4 choose 3 times 2 minus 4 choose 4 times 1. So we got 37. Look at that. Look at that. We even got the combinations thing. We even did that. Alright, we figured out the combinations thing. Okay, we notice things. Okay. Oh my god, what is this? Should I use more? What is that? What is that? What is this? This is a lot of hell nah, bro. What is this? Oh my god, no. Alright, whatever. Let's not look at that. So given 2 sets, A and B. Alright, so we got that. How many elements are there in total? Alright, 9 plus 7 minus 2. Okay. Okay. Now we got 3. Okay. Okay. Let's try this. So we got 16 plus 14 plus 20 minus 7 minus 7 minus 7 plus 4, right? 3 is what I got. Okay. Okay. I'm just trying to get that juicy check mark that goes right here. Okay, so now, yeah, we just got the thing here. So, my god, I don't want to have to type that all out again. Alright, I'm gonna borrow my previous calculation. So there's 3 for all of them, and then for the 3 pairs, there's 2. Right, okay, and then the 3-way, wait, no, yeah, 3-way, there's 2, and then the 2, there's 5, and then 15 for individual. Wait, I already did this. The calculation did not change, the only thing that changed was the 3 at the end. Literally, it was like the same as this, almost. Thank the lords for that. Thank the lords. Okay. So they're saying that if they are all, if the collection of sets is mutually disjoint, so all their intersections of all of them in any ways, all of them are empty. If none of them intersect, then you just add them all up. So that's okay. How many 5-bit strings contain the string 100 100 as a consecutive substring? Okay. Interesting. What is the cardinality of each set? Isn't it just 4? Right? 4? Because I'm not gonna explain it. So anyways, A and B this has to be 0, right? Because this does not, there's like a 1 here and a 0 here. This doesn't work out. Alright, whatever. So A and C, same deal. B and C is probably, yeah, same thing. How many 5-bit strings have 100? It's probably 4, right? 4 times 3, because there's 4 in each of them, and none of them intersect, so you just add all of them, and there's 3 of them, and they're all 4, right? Okay. Bro, it smells like eggs right now, or something. I think my sister is cooking like eggs, bro. I'm hungry, but I'm gonna have that later. God damn it. Hey, look, it's been 52 minutes. Alright, don't you think we can play some Erasio? Alright, we can play some Erasio. Alright. How long should we play Erasio? Maybe like 10 minutes, guys. 10 minutes, my friends. Alright, let's play. Let's see. There's not that many what the hell? Wait, so growth, arms race, outbreak, maze clan, something. I can't even read that. Whatever, man. Alright, so we're in the base clan. Okay, so this is outbreak. So when you die, you turn into a zombie, I think. I kind of want to see that happen, so I'm gonna go somewhere real quick and just to die. So let's see, let's get max these out individually. So we have movement speed, reload, and all that other stuff. Pretty nice. You see that, guys? I tanked that freaking thing. Alright, I'm gonna let this guy kill me. Let's see if I turn into an outbreak person. Oh, it's working. Oh, look at that. 2 zombies? That's pretty good. 2 zombies, okay. Oh. Hey, he's gonna die. Alright. God damn it. Alright, let's try something else. So let's do the toppler. I know the toppler is pretty good. Okay, so I'm gonna do the toppler with some health and bullet speed. I'm gonna let this guy kill me. Oh, please. Don't kill him. Please. Oh. Okay, look, it's super boring. I'm gonna make a zombie team. Alright. Okay, I think I have to die first. Probably have to die first. Let's put the player names on so we can see what's happening. I want this dude to kill me. Please. Oh, come on. I was gonna let you get a free kill. Oh my goodness. Come on. Where are the people at? Where are the people at? This is too much. There's too many players in the base team. We need like a underdog team. This is like too boring. I'm trying to make like an uprising here with the zombies. Okay, Okay, we got another toppler. Let's just see if he can kill us real quick. Yes, sir. Look at that. Oh, okay, he died pretty quick. Are these people in a team? Because I can't see their names. Alright, let's refresh. Let's turn it into the zombie clan that we just made. There's nobody on our team. Oh, who just... Who just... Who just did that? Okay, I'm gonna get max health. Here's the OP strat, guys. You kill someone, so they turn into a zombie. And then you let yourself be killed by them, so you get maximum, like, zombie-age. Look at this. Now there's 3 zombies, alright, on the zombie team. But this isn't gonna work because these wrenches are just here, like, literally, like, targeting. Okay, so my goal is to take down, like, one person at least, and then let that person kill me as a zombie. Oh, here we go. Zombie. Zombies! Okay, okay. There's, like, okay, there's a good amount of zombie. Oh, no, there's some casualties. There's some casualties. Okay, we're trying to spread the virus. Alright. We can do it. We can do this. Maybe not. There's a person here. Let's try to get this kill. Oh. Okay, there's a lot of oh, look at that. Yes. Yes. It's a zombie. Please. Please. Oh. Yes, sir. Okay, we got a little horde going on. Oh my god, please. Look. Oh my gosh. This is so hard. How do you... What is a good, like, zombie horde thing, you know? Good zombie horde tank. Okay, I'm thinking the Gale, maybe. Let's try that. Alright, let's get killed by this thing. And I don't know. Ooh, the thing, that would be a good zombie tank, I think, because he'd be, like, shooting at the other people. He might one-shot them. He might one-shot them, but I'm not sure. Alright. Okay, let's get killed here. Let's get killed here. Get some zombies building up. Ooh, you look at that. There's a lot of zombies down here. There's a lot of zombies down here. Look, part of the horde now. You're part of the horde. Okay, I like this. I like this. Alright, let's get a clunker on the zombie team. And let's see if we can at least kill someone here. Please? Oh my god, what is happening? Look at that. Oh. What is happening? Okay, oh, this guy turned into a zombie. Oh my goodness. Zombies up. Oh my god. Okay, let's see. Let's get a Leviathan on the zombie team. We're gonna need some Leviathans on the zombie team. I think there's too many, I mean, there's not enough firepower, you know what I'm saying? Alright, let's get... I don't think we're gonna... Wait, did I just kill someone? Upgrade my health. That's the first thing I do as a zombie. I want some tanky zombies, you know what I'm saying? Oh my god. Okay, this is the ooh. A wrench zombie. A wrench zombie. That might be something. That might be something right there. Alright, let's see. Oh, there's another guy. Oh yes, please. Oh, look at that. This guy's gonna be a zombie. Please. Oh. No. Kill that guy. Kill him. Turn him into a zombie. Oh my god, no. Alright, I'm turning into a zombie. There's no saving it. There's no saving it. Oh, is he trying to kill? Oh my god. I don't know what is a good, like... Okay, what if I did the freaking... This one. Alright, what if I did this one? Can I kill one of them? Oh my god. I don't know what to pick. Okay, what if I picked the hurdle? Alright, because the hurdle is pretty good for zombie activities. Right? Zombie activities. Some of these people have to turn into zombies. Come on now. I can't just die like a dog. Oh, 2 zombies. Oh, okay, there's too many. There's too many people. There was way too many people. They're all on the same team. That's the thing. That's the thing. There's so many of them. Oh my god. All right. What if we get let's get this one. Okay. So I need some movement speed and some health. I'm gonna try that out. See if I can get something going on there. Try to kill this guy. Hope maybe. All right. Maybe my zombie will kill him. Oh, come on. He could. Damn it. Oh, the invisible. Okay. Okay, that might be a good one. That might be good. Okay, so this one, I think it was this. Slinker, was it? Rogue? Yeah. Okay. I still got it. This guy is invisible to the motherfucking the wrenches. So I have a chance. This zombie has a chance of surviving the wrench, the auto shooting, auto aiming tanks. Oh, come on. Give me a chance here, guys. I'm trying to make a zombie army. You can't just... There's only one of me, alright? This is a tough... This ain't easy, alright? Let me just... This ain't easy, bro. Okay, I have another idea. Alright, this is gonna be my last life. Okay, this is gonna be my last life. Okay, I know the timer went out. Let's try... Let's try this one. Try mech... What is it, Septimech or this one? Let's at least put an auto shoot thing on it. Let's try that. Oh, I picked the wrong upgrade. Come on, man. I'm trying to be a zombie right now. What are you trying to do? What are you trying to do? You trying to kill the zombies? Alright, that's the fun of this game mode is the zombies, alright? So you gotta let the zombies happen. Alright? You gotta let the zombies happen. Okay, let's try this one. Alright, put some health on him. Put some health on this zombie. I know I'm gonna turn into a zombie. That's my one and only goal. I'm trying to populate. Oh, here we go. Here we go. Low zombie population. No, the wrenches. Oh, god damn it. Alright, this is a fun game mode. This is pretty fun. I like being like the underdog in the Erasio. It makes it more fun. You know, more opportunities. Back to discrete math. It's fun like discrete math, alright? Discrete math is equally as fun. Alright. Learning is good. Alright, learning is fun. This, I don't like this. The compliment. I don't like using the compliment. Alright. Oh my god. What? Consider a situation in which a person has forgotten their PIN, and the PIN can be any string of 4 digits, and U is all the PIN numbers. Look at that. So if, excuse me, the person remembers that at least one of the digits is 8. Jesus. Alright. So if one of the digits was 8, you know, we would remove all the digits that don't have an 8, I guess. Well, what? No, that makes sense. That makes sense. So like all the digits is 10 to the 4, because you have 10 digits and there's 4 of them, and then if you don't have an 8 in there, right? That just means you have 8. You have 9 digits left or whatever. Let's see what that number actually is. I'm kind of curious. 3,439 instead of 10,000. So that's pretty cool. What is that reduction? I don't know, bro. I don't. Oh my god. I don't know why I'm calculating this. Yeah, obviously, like 30, 34, a 70, almost a 70% reduction. All right, let's get that check mark. Let's get that check mark. Okay, so this, I might have to actually go through this. Okay, so we have a set of all of the digits. These are all the digits. And it looks kind of complicated. Oh, that's what they were trying to tell me. Like, even though it looks complicated, you don't use the complicated part. You just count the overall shape, in total what's in there, and then you could subtract that from the universe, you know, the other stuff, and then you could tell like how many things are in there, I guess, right? Is that how that is? How that is? So not the union is outside, I suppose. So how do they do this? So P1, 2, and 3 is where they have an 8 in that place. And then, so if you go out of that, it means it does not have an 8 in that place. And none of the digits would have an 8. So you just get the whole thing, subtract this part in the middle, and then you get the rest of it. Okay, that makes sense. Yes. Alright, let's do it. Bro, I'm actually getting hungry now. I'm getting hungry. Oh my god. Okay, the problem is that I can't pause this. I think I can't pause this. Is there like a pause? Oh, yeah, it's because I did this. Yeah, whoops. Okay, so I can't pause this because I put something in the settings. God damn it. God damn it. I should have known. I should have known. Nah, JK. I didn't know. I couldn't have known. I didn't search it up. And I didn't check. Oh my god, bro. Is this mesmerizing? Alright, is this mesmerizing? This is pretty cool. It's like the screen, you know, and then you got this stuff going on. Alright, let's see. Oh my god, dude, I gotta do this. Okay. Okay. Oh, so how many 4-bit strings? Oh, I think I broke it. Okay. How many 4-bit strings have at least have a 1 in at least one of the first 2 places? Okay, so how many 4-bit strings have that? I think I can. I think I gotta count that, I guess. What is that? So like all the digits. What is this? How many 4-bit strings have a 1 in at least one of the first 2 places? Is okay, so I'm gonna do something. I'm gonna write down that okay, so I'll put that in the ones place, like in the first digit is a 1. So I'll put like first and then second. Okay, and then okay, so I'm gonna count these And then I'm going to find the intersection. Alright, so first and the second. And then I'm going to find their union. Right? And then, okay. So the first thing is if there was a 1 in the first place, how many strings is that? So that's literally like 2 to the third, right? 2 to the third. Okay. And then also the second thing is also 2 to the third. And then 2 to the second for the intersection. Okay. Okay, so I do 2 to the third times 2. Okay, and then I do minus intersection is 12. Right, okay. Okay, so here's Erica again. Okay, so she goes swimming 3 out of 7 days a week. How many possibilities are there if she goes swimming on Monday or Tuesday or both? Okay, we already calculated this, right? Then we already calculated, is this 25? They gave the same question twice, but on the previous assignment, the previous lesson. Oh, they wanted me to do it with a freaking compliment. Bro, I refuse to use goddamn compliments, dude. I don't like them. I don't like using it. It doesn't make sense. I don't want to learn it, bro. That's not funny, but it could be funny. All right, it could be funny. I'm doing it still. I'm getting the questions. Oh my god. I'll see if I need them, cause when I get to this part, like, and I can't do them, I'll learn combinations if I have to. Okay, so John plays hockey 5 of the 7 days. How many possible schedules are there to play hockey on Tuesday or Monday or both? Okay. Okay. Let's let's check that out. Let's check that out. Okay. So he plays hockey 5 out of the 7 days of the week. Right. And how many ways are there for him to play hockey on Tuesday or Monday or both? Okay, so that's the union of those thingies. This is what confuses me always. The intersection. I still kind of don't get it. Like, how would I know, like, to subtract if it was both? How would I know to have these 2 sets? Okay, oh, that's probably what I gotta do. I gotta figure out, like, it's gonna be like 2 sets. Right? I mean, I already know that, but I just don't get it. Like, I'm trying to figure out, like, a formula or something, or, like, when to use this. Okay. So, how many possible schedules are there to play hockey on Tuesday or Monday or both? You know what? Because Tuesday and Monday are disjoint, but both is not disjoint. So I think that means that's when I use the principle, I suppose. Now I'm confusing myself. Wait, what? So, hockey on Tuesday. So he plays hockey 5 of the 7 days of the week. How? Okay, well, let me just do this. All right, let me just figure it out. Okay, let me just figure this out. Okay. Let's say I had 7 days. What if this was a counting problem with what's it called? I think it's a subset thing, right? Maybe. So he picks 5 days of the 7. Okay, let me just do. So if he picked Tuesday, oh, that's probably what I gotta do. That's what they've been showing me, right? Like the bit strings. I know it doesn't make sense. Okay, so Tuesday. Like if he chose Tuesday, then his possibilities for that would just be 6 choose 4, right? Because yeah, so 6 choose 4. And Monday would be the same thing. Okay. And both would be motherfucking. Bro, I already know this. I already know this. So both of them is 5 choose 3. Right. 5 choose 3. Yeah. 5 choose 3. 5 choose 3, okay. And the union is... So I kind of get this now. I kind of get this. So if I'm able to represent this problem in the form of sets and intersections of them and unions of them, then I can use like the formulas that they're talking about. And you know, that kind of makes sense. That kind of makes sense. Cool. So okay, so 6 choose 4 times 2 minus 5 choose 3, which is 20. Okay. So, okay. There's another, oh my god. How many minutes in total did the team have? At least one of them playing. So I'll use the power of sets, and I'll union all of them. They play on the same hockey team. They play for this, play for that, play for this. Each pair played for 5 minutes. All 3 of them played for 3 minutes, 4 minutes. And how many minutes in total did the team have? At least one of them playing. So that's counting the minutes that all of them played. Wait, what? I have at least one playing. Okay, so I guess that's the union. So okay, so I'm gonna do 14 plus 18 plus 15 minus, wait, minus what? 5 times each pair. Each pair, you say? Pair, there's 3 of them, so 3 choose 2. Very nice. And then we add the 3 choose 3 thing, and then we got 36. Awesome. So suppose you're using the principle to compute the number of elements in the union of 4 sets. Okay. Interesting. Okay, so yeah, so so there's 4. Oh my god, bro, it's the same. So it's the 4 choose 1 times 15 minus 4 choose 2 times 10 plus 4 choose 3 times 5 minus 4 choose 4 times 4. Okay. Interesting. Interesting. This one's a lot less information. So Sue only plays basketball on Tuesday and Wednesday. John only plays basketball on Saturday and Sunday. How many days a week does at least one of them play basketball? 4, because yes, you just count them because none of them play on the same day together. So that's okay. So Dave forgot the password. He remembers the password was made of lowercase vowels, was 5 characters long, and contained at least 1 A. Okay, so yeah, I think this is the final boss of this lesson, or not. This is looking kind of weird. Kind of weird, but whatever. Okay. Okay. 1, 2, 3, 4, 5 options. 5 characters long. Contained at least 1 A. So I could calculate the 5 intersection weird thing. Contained at least 1 A. How does that work? Can I just calculate this, like, manually? I don't want to do the complement. I don't want to do the complement. I don't want to do. So it says it contains at least 1 A. So I can just add up all the possibilities. Like if it has 1 A, 2 A's, 3, 4, 5 A's. So yeah, I could do that. Let's try that. Let's try that out. Let's try it out. So if I had 1, 2, 3, 4, 5, and then so if I had 1 A in it, we would say 10 per no, 10, what was it? I think it's just 5 choose 1, right? 5 choose 1? 5 choose 1 different, like, positions that the A could be in, right? So it's 5 choose 1 times, and then the rest of the thingies. So we already used up the A's, and then we say there's 4 characters left, and 4 what is it, 4 to the 4th, literally? It's just 4 to the 4th, because we have an A. We used A, right? So now it's 4 characters long, and we used the A, so we're not gonna, there's only 4 thingies left, so yeah. 4 to the 4th. Okay. So if it had 2 A's, that would be 5 choose 2, right? 5 choose 2 is 10. 5 choose 1 is 5, whatever, okay. Wait a minute, 5 choose 2? 5, nah. Nah. 5 choose 2, 10. 10? 10, but they're the same. How is it gonna have more options like that? No, that actually makes sense, never mind. Never mind. Okay, so it's gonna be 4 to the 3. And I think I figured out the pattern. We just go like this. Go like that. 4 to the 1, 4 to the 0. Okay. I could write write this all down, but I could also use summation. So I'm gonna do that. So x equals 1 to 5. We are gonna do the sum with 5. Dang, x and 4 to the 4 minus x plus 1. Right, is that how that works? No, it's just 4 minus x. Yep, okay, and then we plug that into the calculator, okay. 5 choose x, 4 to the 4 minus x. We get 2 1 0. Okay, is this even, is this right? Is this right? No, I got a fraction. How's that possible? That is not possible. I got a fraction. How do you get a fraction? No, this is, you're only multiplying. We're not dividing anything. Nah, bro, this is not possible. Got a fraction. Did I put this right? I don't think I did. I don't think I did. This can't be right because I put, wait. Because 4. Oh, it is actually plus 1. I was right about that. Whoopsies. Whoopsie daisies. Okay. So yeah, it's 2 101. Look at that. I could have used the complement, but I refused. So I made a summation thingy, and it works as well. It kind of works. All right. So my goodness gracious. Okay, what up? Let's see. I got scared for a second. Me no likey loud noises. That's alright. It wasn't even that loud. So nah. I like loud noises, but like I don't even know, bro. I don't even know, bro. I mean, I do know. I'm not gonna say that's too tweaky. That's too tweaky. Alright. So count the number of strings of length 9 over this alphabet. Oh my god, there's so many restrictions. Why? Okay. So the first or last character is an A in a string of length 9. Oh my goodness. Alright. Okay, so let's say the first character can I count this without using the intersection thing? Could I actually do that? Number of strings like 9. So if there was no requirements, it would just be 3 to the 9. Right, so the first or last character is A. Nah, bro. I think I'm gonna have to use intersections. Yeah, I'm gonna use okay, so first and last. So first has 3 to the 8 possibilities, and the intersection is 3 to the 7. Okay, so we got 2 times 3 to the 8 minus 3 to the 7. Okay, we got that. Okay, and then here they're saying the string contains at least 8 consecutive A's. I mean, isn't that... Wait, hold up. Hold the phone. We gotta work out how many cases there are for that to happen. So like, if the first, I mean, if you have 8 consecutive A's, it can be in one of 2 positions. Because the length of the string is only 9, so you only have 1 space left to move that 8 A's. So that's 2 different positions. And then, okay. So 2 different positions. For each position, you would have 2 possibilities left. 3 possibilities left. So, isn't it just 2 times 3? Right? 2 times 3? Nope. Okay. Mine. 2 times 3? What are you subtracting? We're subtracting the... where they get counted twice? Oh, yeah. Nice. Okay, so they get counted twice on that. That's... okay. I need to clutch up, dude. I need to clutch up with that. This is literally what I'm supposed to be practicing. The formula. The intersections. I have to subtract the intersections because they have some. This one had intersections and I used it. This one I tried to do straight up and without even considering the intersections, and that's not good. Okay, let me try to do it again. Okay, so the string contains at least 8 consecutive A's. Right, so let's just like calculate that. So there's only 2 positions for that, so I'll call that A and B. Let's call that A and B, and let's say we can take their intersection, and yeah, their union is gonna be the thing that we want to get. Okay, so A is gonna be the first case, right? So the first case, I'll just say, is the A's are on the left most side of the string. And how many possibilities is that? That's 3, like I said. Because the last character, there's only 1 character left, and we only have 3 things in our alphabet, 3 symbols. So, and it's gonna be the same for B. And their intersection is 1, and I know that because I saw it here, but would it make sense? I guess if there's 2 A's at the end, that would satisfy both sets, and that counts for the intersection. So yeah, so you would add them with the union. You would be like 3 plus 3 minus 1, and the union would mean this, at least 8 consecutive A's, because we constructed it to mean that, because the A is 8 consecutive A's on the left side, B is on the right side, and like if we want either case, then you use union and you count it. Okay, makes sense. Okay, so this one is god damn it, this one's kind of weird. So the string contains at least 3 consecutive identical characters, so not just the A, it could be A, B, or C. Okay, so I think we gotta count that, so I'm gonna do that. We're gonna do that. So, okay. So if we had the 8 consecutive characters on the left side, that's 3 times 3 possibilities, I'm guessing, because we could have 3 different characters for the consecutive thing, and then the last digit is 3 possibilities. And I'll say it is the same for B. Okay, and then the intersection is if they're all the same. So that is just 3. Yeah. Okay. So um yeah. So 3 times 2 minus 3 is 15. Right. Okay. Okay. Interesting. So the first character is the same as the last character, or the last character is A, or the first character is A. Oh my god, what? The what? So, or the last character is A, or the first character is A. That's a weird, so that's like a union of all of these. So there's 3 sets here. Okay, so there's 3 sets. Alright, let me write that down. Let's write that down. Okay, so the first thing is if the first character is the same as the last character. I'll call that F, or I'll call it S for same. Okay, so same is the first character is the same as the last character. Wouldn't that be... isn't that like 3 times... What? Because like if they're the same, that means you only choose the first one. And then the first one is only 3. So isn't that like 3 to the 8? 3 to the 8. Because you don't choose the last character anymore. You just choose the first one. Because you already know the last character is the same as the first one chosen. So you just choose the first 8. And then the 9th one is like just the first one. Okay, so I guess that's 3 to 8. So that's that. And then, so this condition is if the last character is A. So if the last character is A, I'll put L for that. Last character is A. Isn't that 3 to the 8th as well? Because you just... aren't they all 3 to the 8th? Let me just write that down. So last equals 3 to the 8th. First equals 3 to the 8th. Because you're just choosing one character. You have 8 left. And on this one, you're still just choosing 8 characters. Oh my god. So let's write down all the intersections. So we have same and last. Last and first, and same and first. And then we have the intersection of all of them. Okay, and then we're gonna write out the formula, and they want the union of all of these. So yeah. Okay, so same and last being... okay, wait, what? So the first character is the same as the last character, or the last character is an A. So if the first character was an A, then the last character would also be an A. So what is that supposed to be? What? First character A. Is that 3 to the 7th? Cause now you're just now you know that the first character is gonna be A. Because they're telling you that the last character is A. So now you just pick everything in between, right? Is that how that worked? 3 to the 7th. I think. Right? And this is gonna be the same for the other same and intersection thing. So okay, so last and first character being A is also 3 to the 7th, because you're just picking 2 characters. And the intersection of all of them, isn't that also 3 to the 7th? Because you're just saying that the first character is A, the last character is A, which this one is that's the same. That's what this is saying. So you would just be picking everything in between the first and last character, which is also 3 to the 7th. Okay, let me add that up. Let's add that up. So 3 to the 8th times 3 minus 3 to the 7 times 3 plus 3 to 7. Oh, they don't give the number? I think I got it, right? 3 to 8 times 3 minus 3 to 7 times 3 plus 37. Yeah. Alright. No, actually, let me calculate this. Let me just check. Okay. Yeah, I got the same thing. Okay. That was funny. I mean, that wasn't funny. I didn't laugh at all. It was a little confused. I was a little confused there. I was unsure on that one, but I'm glad I got it. Okay, so the string contains at least 7 consecutive A's. Okay, oh my god, what? So this one, we did 8 consecutive A's, and I went through all the cases where that could go for that, and I made a set for every case. This one, I am assuming I could do the same thing, but now it says 7, so there's gonna be more cases. Not too many more, but yeah, still. Nah, bro, I don't want to do that one. There's gonna be like 4 cases, and then I want to find the union of all of them. 4? That's like that's the whole thing. That's that whole formula that was up there. Okay, how did they do this one? No, they actually did it. Nah, okay. God damn it. Alright, whatever, I'm gonna do it. Okay. So the string contains at least 7 consecutive A's. Hello. I'm recording a video, but what? Oh god. Oh, thank you. That's funny. The rice is ready, my friends. I wish I could pause this video. I'm thinking about it. I think I'm just gonna end the video. Alright, I recorded a video. I'm trying to record some videos, you know, getting to it. you know, I recorded a video. Satisfied. I did my thing, you know, a little ratio. I added that beautiful hand cam. You could sort of see what was happening. I hope it's not too distracting or whatever. Oh well. Alright, I'll see you guys later. Thank you for watching. If you did, have a wonderful day. Have a wonderful day, everybody. Thank you for watching.